Hi everybody, this is Mrs. Lehman. I hope you're having a great day. Thank you to the substitute for holding down the fort while I'm out, and thank you to the students for being so helpful and attentive and, being the wonderful children that you are. I truly do hope that you have a great vacation, but until then, we do have some questions to go over. So you will be receiving the Module 2 review packet, which is made up of questions from the past few years' state tests that all involve skills for Module 2. So in this packet, what you're going to see is a lot of dividing fractions questions. That's on the first page. When you get to the second page, it's going to talk about greatest common factor and some least common multiple questions. And then there's also going to be a part 2 or a few part 2 questions that involve the same type of skill set. So there is one question that I would like to go over with you before you get started, and then we're going to talk about some of the skills we learned in Module 2. But the first thing is, if I could have your attention to look up here and divide fractions, this bell ringer, using a model. Now, we didn't use a ton of models in Module 2 because I think it personally is just more efficient to do it with the old algorithm, copy, dot, flip, keep, change, flip, etc. But you do need to recognize when you see something like this, what is happening, okay? So in this example, you'll see that there are 2 1/3 boxes shaded gray, okay? And it is being cut into sections that are 2/3 of a unit. Okay, so we have 2 1/3 being cut into 2/3 units. So the question asks which equation is represented by the model. So if you can at least recognize that you have two whole numbers, amounts filled there, and then 1/3 of another one, and then you're cutting it into 2/3 sections, that could either be choice A or B. So really what separates choice A from choice B is the answer, okay? So the answer to these for A is 3 1/2. That's different from choice B, 3 1/3. So this question was confusing. A lot of kids got this wrong a few years ago. So let's talk about this. If you come across something like this, you guys are really good at copy, dot, flip. So why wouldn't you use it here, right, to see which one of those two is correct? Well, the correct answer is choice A. And the reason that is because you have one section. It's divided into 1, 2, 3 sections. You can see 1, 2, 3 right here. And then here would have been the 4th section, but only half of it was filled. So you had all of these 3 plus a half of another one. So that's why it's choice A and not choice B. Now, if you don't believe me, again, we have old school math to rely on as well. And with that, we've got a first thing, we got to change any mixed numbers into improper fractions. I'm going to get rid of this answer because we're going to really test to see if that's accurate. So we're going to turn any mixed numbers into improper fractions. So 2 1/3, if we were to convert that, multiply your numerator, multiply your denominator and your whole number, add the numerator. So you're going to get 7/3 divided by 2/3. Now notice, I didn't try to copy, dot, flip yet. My first step is to get it ready for the operation that's going on, right? Division. So now that it's in the right format, now we copy, dot, flip. So 7/3 times 3/2. You could go ahead and multiply that ahead of time, or you could simplify before you multiply, which I like to do. That would simplify out that 3 as a numerator and 3 as a denominator. So 7 times 1 is 7, and 2 times 1 is 2. So that equals 7/2, which is otherwise known as 3 1/2. Okay, so the correct answer is choice A. Okay, that's one thing I wanted to talk about with you quickly. And I'm going to pause this for a second. Okay, this question was challenging for a lot of kids a few years ago. All right, and it was challenging when we had it on a Module 2 test in the classroom. But either way, it says Jason will use a 1/3 gallon pitcher to fill an empty 3/4 gallon water jug. So he's filling something up with 1/3 gallons. So he continually brings over 1/3 gallons until, it's until that 3/4 gallon water jug is full. And it says how much water will he need in order to completely fill the water jug. So you've got to decide what number comes first. So what number comes first in this situation? Well, you're trying to figure out either what's being divided up or what's being, in this case, filled up. All right. So the one that's going to be essentially split into 1/3 gallons is that 3/4 gallon jug, because we want to figure out how many times 1/3 fits into it. So we're going to take 3/4 and divide it by 1/3. That's the biggest battle right there, is figuring out what number comes first. In this case, 3/4. All right, so we're going to copy the first number, 3/4. We're going to change that division. I'm going to scroll down a little bit. We're going to change that division to multiplication, and then we're going to flip the second number. And when you do that, you're going to get 3/4 times 3/1. All right, 3 times 3 is 9. 4 times 1 is 4. So 9/4 is the same as saying 2 and 1/4, 2 1/4. So, of course, that's not, the answer. We've got to figure out what these say. It says, how much water will he need to completely fill the water jug? Well, he's not going to need between 1 and 2 full pitchers. He's going to need 2 and then some left over, right? 2 1/4 trips is what he's going to need with this 1/3 gallon container he has. So it is not between 1 and 2 full pitchers. 2 1/4 is, just doesn't fit that description. Choice B, between 2 and 3 full pitchers. That is the correct answer, because 2 1/4 is between 2 and 3. And if he only had half of a third, that's not going to fill up a 3/4 of a gallon container. So that doesn't make sense. And choice D doesn't make sense either. So he needs between 2 and 3 pitchers to fill that 3/4 gallon jug he's got. All right, so anyway, I wanted to review a few things with you before we flip over to our packet. So now that you have your packet, hopefully, we are going to review some things, all right? So operations with fractions. Key focus here is dividing fractions. That's one of the things in Module 2. Another thing we're going to talk about is GCF, LCM, but we'll talk about that in a minute. So let's quickly review dividing fractions. All right, so you have to recognize when something's being divided. So this happens a lot when you're splitting a quantity equally, you're sharing something amongst people. Serving size, I should have added that, like maybe not serving size, but it'll give you a quantity of cookie dough and you're dividing it into serving sizes. Or trail mix, if it's New York State, right? They love trail mix questions. And they'll divide it into, 1 cup servings, how many cups can be made. Quotient, anytime you're splitting something up amongst people or into sections of any sort, that is a division problem. So you would see any of these words. How to divide fractions, we already talked about this. You got to multiply by the reciprocal. That's the old school way that most of the teachers around here learned it when they were kids. We didn't have these fun copy, dot, flip sayings, or keep, change, flip, or drop, switch, flip. But again, that's what you need to know. Now the next thing we're going to talk about, oops, I want to go back. Again, you want to make sure the first step is to change any mixed numbers into improper fractions, then you copy, dot, flip. Okay, so make sure you've converted it, get it in the right format. Don't be quick to copy, dot, flip. That's where kids make mistakes. So again, get it in the format first, then copy, dot, flip in another step. All right, so we're going to go over some questions with that, but before we do, let's also talk about LCM, least common multiple. Least common multiple, if you look to the left of the board, you'll see the LCM in the heart carved into the piece of wood, because we like to say that that's the first time numbers will bump into each other on the number line. So I like to give this example that my friend Judy and I, we were getting our hair cut, at different intervals. I ran into her one day and I said, "When will I see you again, Judy?" And she said, "Well, I get my hair cut every 6 weeks." And I said, "Oh, I come every 4. And my hairdresser and Judy were trying to figure out when we would be meeting up again. And I said, okay, well, I'm coming in 4 weeks to the hair salon, and 8 weeks, and 12 weeks, you're going to be here, at 6 weeks, and then again at 12 weeks. So the first time we're going to meet up with each other again is 12 weeks from now. It's not the only time we'll meet up again, but every 12 weeks we'll see each other. So I'll be on my 3rd haircut, Judy will be getting her 2nd haircut, okay? So there's lots of different ways that these questions are worded, but essentially you're skip counting by a number until the numbers meet, okay? And it's the first time you're looking for the least common multiple, so the lowest value multiple, so that's the first time they meet. Let's take a look at GCF. GCF means greatest common factor, and factors are numbers that are multiplied to get a product. So you break a number down into factors, okay? So you can use a T-chart. So for example, if we're finding the factors of 24, we're looking for a list of all the numbers that will multiply to give you 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, okay? And those are all of the factors of 24. Now, that's one way to find the factors. Now, let's say I wanted to say, what's the GCF, greatest common factor, of 24 and 36? Okay, so I could do the same thing with that. 2 times 18, 3 times 12, 4 times 9, and then we have 6 times 6, right? So when you look, the greatest number, I'm going to start on the right-hand side of my chart and find the biggest number that's common to both list of factors, and that is 12. So the GCF of 24 and 36 is 12. Another method that we've talked about is the factor tree. So if you have a particularly large number, a factor tree is a little more efficient. So what you got to do is think of 2 numbers that multiply to give you that number on top. So 24, okay, what if I want to say 3 times 8? Okay, you could have picked other things. Anytime you come to a prime number, you got to circle it because you can't break that down any further. All right, so if it's composite, if it does have more factors than 1 in itself, like a prime number, 3 only has 1 and 3, we don't want to just keep breaking it down into 1 and 3, right? But 8 is composite, so we can break that into 2 times 4. 2 is prime. We bring down the 3 from this one, right? 4 needs to be broken down. That'd be 2 times 2. And when you're done, you're going to have a list of all prime numbers at the bottom. So the prime factorization of this is 2 times 2 times 2 times 3. And if you multiply all those numbers, you should get 24. All right, for 36, let's say 3 times 12. All right, 3 is prime. You can't touch that. You can't break it down. To get 12, I could do 3 times 4. 3 is prime. I'm going to bring down this 3 that we had before. Okay, now I'm breaking down 4 into 2 times 2. And you never write a 1 in a factor tree because, we're trying to break it down into factors greater than 1, and every number has a factor of 1, so it wouldn't make any sense to do that. All right, so again, these look similar, but what you do is you look at each list. So we have 2 times 2 times 2 times 3 for the prime factorization of 24, and we have 2 times 2 times 3 times 3 is the prime factorization of 36. We're looking for common numbers that are in both lists, so I like to say they play Go Fish. All right, hey, do you have a 2? Yep, they both have a 2. They have another 2? You betcha they do. But after that second 2, they don't have any more 2's in common. They do have 1 3 in common. So if you then multiply this list of common factors, 2 times 2 is 4, 4 times 3 is 12. The GCF of those 2 numbers, the greatest factor they have, is 12. So you have 2 options there, all right? So now at this point, the substitute's going to walk you through the questions in Module 2, so you're going to have some time to work on these questions. Again, I can't emphasize this enough. Read each question twice, underline keywords. That's a silly way to miss questions, is not reading carefully. Go ahead and try some of those, and then you'll be going over the answer. So You guys have a great vacation. Honestly, please work hard today, and we'll get right back. Relax for a little over a week, and we'll get right back to it as soon as vacation's over. But until then, have a great time. Bye.